Happy Thursday. I hope you're having a lovely day and a lovely evening. As mentioned, today we are going to be talking about software testing. Uh, excuse me, still getting over a cold. Let me go ahead and share my screen. So this lesson today is pretty important. We're going to talk about sort of the software development life cycle and software testing overall. I'll say there is a lot of text in here, so there's gonna be a lot of talking. I have a couple like videos and examples I found to hopefully make it a bit more concrete for you all. But there is a lot of information. With that said, I do think we can probably talk through this, and I don't know if this will really take the full 2.5 hours. So I'm gonna ask you all to laser in, develop some laser focus for now. We'll get through this content, talk about some of the big ideas behind it, and then perhaps we can leave a bit early if it seems like folks are on top of the content, are able to answer questions that I pose to you all, and it seems like you're getting it. So that's the plan for today. This is part of, again, the sort of Days of a Developer module. So the goal here is to get a survey, a better understanding of what software developers are doing and what the overall software development process is like now that you all have some experience with coding in JavaScript. All right, let's jump into it. So, introduction to software testing. So, in today's lesson, we're going to provide a comprehensive overview of software testing, the essential concepts associated with it, including testing methodologies and the software development life cycle and software testing life cycle. So, I would say there's really two different key ideas today. One is how does software get developed, and the second is how do we test that software. By the end of this lesson, we're hoping you are able to explain the concept and significance of testing and software development, identify and describe the role of testing in each phase of the software development life cycle, and describe the roles and responsibilities of a software tester. All right, so that's what we're going to try and get to today. All right, here's our little scenario to sort of start thinking about testing and the software process. So imagine you're about to board a brand new airplane for a long-awaited vacation. You settle into your seat, the pilot announces that they've completed building the plane, but there's one crucial step left, testing. Now think about how you would feel knowing that the plane hadn't undergone rigorous testing before takeoff. Would you still feel confident in its safety and reliability? Just like in aviation, software undergoes testing to ensure it operates smoothly, efficiently, and most importantly, safely. Lots of lees on the very end of that sentence. So the idea here is that, a couple ideas. One, when you're coding, I hope that you all write perfect code for the rest of your life and nothing ever goes wrong. But it is likely that you'll write some code and it won't necessarily work as intended, or maybe it will work as intended, but it might not work with another part of the system, or it might not work with some code that someone else has written, right? So testing is a really essential part of this, so you're able to uh, develop products that are safe for users for sure, but also just, complete their intended purpose. Now, I'm sure you all have come across some issues on software that you've worked with. And so let's go and talk about that for a brief moment. There's all kinds of software brands that have pushed out changes that have not worked perfectly. Can you all think of any that you've experienced in the past, either some frustration that's been caused due to bugs or something that could have been done differently to solve their problem? What are some technology experiences that have functioned a bit negatively for you all? What can you think of? Or hey, perhaps every technology you all work with works perfectly. That would be nice.
Yeah, that would be lovely. But no, it's not.
Yeah, I feel like not quite the case. I can, as you all are thinking, I see a few folks typing. I can share one. Actually, I was trying to join a video call yesterday in Google Meets, which I don't use too often, and I have an external webcam for one of my computers that I use, and uh, for some reason it would like not connect appropriately, and my screen would be like on a third of the window for Google Meets, and I was like futzing around with Google Meets to get this to work, and something just kind of annoying. It's a little bit frustrating. How about you all? Any technology frustrations, perhaps due to some potentially faulty code or a bad release? Right, Drago shares. Coolest one I know about is when World of Warcraft got plagued by a debuff from a boss or something like that, and the game was unplayable. They also did a study on disease spread based on this. I feel like I remember hearing about that. Yeah. Uh, that something about how it was getting propagated made it so that folks were really struggling to play the game. Nice. Any others you all can think of?
Yeah, for example, last week I had to make like a transfer to my uncle's account, and I couldn't enter like an account longer than 9 digits for some reason. So I
Hmm.
had to reach out the support, and they had to submit a ticket, and it was like 3 days waiting for that, and then they changed that, and I was like, why do I have this blocker here if the accounts for
Yeah.
are this long?
Yeah. Yeah, thanks for that. That's a great example. It's just like sort of a lack of imagination about what kind of inputs that people could put in here. Yeah, for sure. All right. Well, there's been some, and we'll hear about these in just a moment. Some particularly bad bugs that have shown up. So when we uh, talk about testing in general, again, this overall lessons on testing, although we're going to talk sort of generally about the life cycle of software development, but we're talking about testing. The idea is that testing is like checking something to make sure it works the way it's supposed to. It's like when you want to make sure a toy isn't broken before you play with it, or when you taste food to make sure it's cooked right. Testing helps us find out if something is working correctly or if it needs to be fixed. Software testing is like giving software a quality check before it's used. It's similar to inspecting a new gadget to make sure it works smoothly. The goal of software testing is to make sure that software does what it's supposed to do without any problems or glitches. You all have actually done some testing. So when we have been working on our algorithms, often at the end, that lab will say, "Hey, go ahead and test your algorithm with an array that has uh, set of numbers, set of negative numbers, set of duplicate numbers, right? That is essentially testing. We're setting up a scenario where we're saying, okay, I want my function to work this way with this kind of input, and then writing some code that'll test out whether or not that is indeed true. Really at its lowest level in terms of like software testing in particular, we could just do exactly what we've done in this class, which is write a function and write some console log statements underneath it to ensure that things are working as expected. Of course, once we start to look at code bases that are really big, just a bunch of console log statements don't quite do it. And so some interesting frameworks have been put into place to make it easier to test. But that's the idea, is to test out your code at a variety of different levels to make sure that the functionality you want in your application is indeed there. All right, so talk about a few real life incidents that demonstrate the importance of ensuring software reliability and quality. So here are a few. So in the 1980s, software defects in the, I'm going to guess this is Therac 25 radiation therapy machine caused fatal errors leading to the loss of lives for some patients. In 1996, the Ariane 5 rocket worth $1 billion, which is a lot of money. I feel like we throw around billion now like it doesn't mean anything, but $1 billion is a lot. It was destroyed due to a software bug in its guidance computer uh, just seconds after liftoff. And in 2011, Honda had to recall millions of vehicles globally, including the popular Accord sedan, due to a software issue that could damage the automatic transmission. So these are kind of the worst case scenarios, right? These small bugs led to loss of life, loss of tons of money, a lot of pain for consumers potentially. These are kind of things that we certainly want to avoid in the products that we're working on. So these examples highlight the significant impact that software defects can have on individuals and organizations. They can harm a company's reputation and result in substantial costs associated with fixing the problems and potential legal liabilities. Therefore, ensuring the quality and reliability of software systems is crucial to prevent such issues and maintain the trust and confidence of users. We have a couple questions down here for you all to answer. So go ahead and take a moment. I think we probably need 2 minutes or so. I'll just watch the clock up here. 2 minutes. Go ahead and answer these questions based on what we've talked about so far. And then once we come back, we'll talk about it together as a group. So just about 2 minutes, about 17 minutes after. All right, let's go ahead and come back. Let's talk through these. So, which of the following best describes the importance of software testing in a banking mobile app? What do you all think? And we'll say, yeah, A, B, C, or D. All right, excellent. Got a couple answers in. Yeah, so this second one here, go ahead and check it. So in this case, verifies the app handles user data securely and processes transactions accurately. Yes, this would be, the importance of testing. This is creating a more secure environment for folks. Some of these other details could still be important features. So for example, ensuring the app has a visually appealing interface, make sure the app can be downloaded quickly. Those can still be important things to work on. But this is not really maybe the role of software testing in particular. It's not the main goal. All right, let's talk about the second one. So, which of the following best describes the importance of software testing in a healthcare management system? What do you all think? All right. Thanks, Dragos. Thanks, Asari. Thanks, Chris. Yeah, so this first one here. So in this case, this one says verifies that patient data is accurately recorded, securely stored, and easily retrievable by authorized personnel. Something to note here is that, it's not that testing is just about like protecting bad things from happening, right? So this one says easily retrievable by authorized personnel. The goal here is to have secure data to make sure that things are protected as needed, but it can also be a goal of testing to make sure, hey, this data is accessible as long as you have the correct permissions. Again, these other features can still be something that is important to the app for other reasons. So guarantees that the system includes features for social media connectivity. I don't know what this would be about, but perhaps that's something that's important for this kind of system. Ensure the system has an attractive and user-friendly interface. Those are all good reasons as well, or good features perhaps to add. Uh, but this is the one that is actually sort of in a typical domain of software testing. All right, so I got this last one. Which of the following best describes the importance of software testing in an e-commerce website? Exactly, Dragosh. So that everybody knows. Yeah. All right. C verifies that users can search for products and add them to their cart and complete purchases without issues. So here we're focusing right on just the correctness, the that the app can do what it says it's going to do. Right. Software testing certainly is about that as well. So here, there's not necessarily anything in this description about security or anything like that. But this is just about the application works as it's intended. All right. Excellent, y'all. So that is the goal of testing. So now there are different folks who are involved in testing an application. It's not just one individual or one team. So we'll talk through a few of those now. So first of all, software testers and QA engineers. This is really going to be at either larger companies and or companies that have like very particular use cases or perhaps something where there could be a lot of issues if something goes wrong. These professionals are specifically trained in software testing. They design test cases, execute tests, report defects, and ensure that the software meets quality standards. As we'll see, quality standards is a little bit different than just testing to make sure that code works. But these are all important things. So one role that might be working with testing would be these folks. Software developers are also involved in testing often. I would actually say it says here in some cases, developers also perform testing. In my experience, this is pretty common that developers are writing a lot of the tests, particularly at smaller or mid-sized companies. So developers will often write what are called unit tests, where they check their own code for errors before integrating it into the larger system. We'll look at a couple of examples of these later, but the idea is as you write code, you're writing tests that check that code does indeed work. There are automation testers. This can be a role for sure. These testers specialize in creating automated tests that can be run repeatedly to check for regressions or repetitive tasks. This is essentially setting up a kind of script to run through your web application, your product to ensure that certain flows work as expected. Users and beta testers can also be involved in testing. This is more like a real world example or really like trying something out in person. So particularly if the product you're working on has software, but perhaps it has an in-person component to it, actual users or beta testers are really important to understand, certainly that everything's working, but also maybe how it feels, how it's being received by the intended users. Quality assurance team, this is very similar to up here, but QA teams are responsible for overall quality management, including defining testing processes, standards, and strategies, as well as coordinating testing efforts across different teams. So a team might be responsible for, again, coordinating that testing across multiple other teams in the same company. And product managers are owners. So product manager or product owner is someone who is a bit more connected to the business side of things for a particular product, and they may also be involved in testing. Um, if for no other reason than to make sure that testing is happening. If they're not individually involved, it might just be that they're managing the process. So overall, testing is a collaborative effort involving multiple stakeholders, each contributing their expertise to ensure the quality and reliability of the software. What's important to remember is even though you may just be a software developer at your role, even though you may not have tester or QA in the job title, you may still be asked to test code, even code that isn't yours. Has your little aside. If you haven't been asked, volunteer to do so. You'll learn a lot about your code-based project by getting your hands dirty. Adding tests to something or checking on breaking tests is often a first task for new software developers. It's something that won't negatively impact necessarily the immediate product, and definitely can give you a good sense of how the overall program, application, product works. Excuse me. This sounds so fancy, right? Insights into testing psychology. It sounds very highfalutin. So just a couple things that are important when thinking about testing. There's a lot of details here. We'll kind of walk through them somewhat quickly. Um, it says here, understanding and embracing the psychology of testing is crucial for becoming a successful tester. So these are some things that you want to either develop or want to have in order to be able to test well. So attention to detail is quite important. Testers with a keen attention to detail meticulously examine software systems, ensuring that no potential defects or issues go unnoticed. This mindset is essential for thorough and comprehensive testing, as even minor oversights can lead to significant issues later on. I'll add to this. Attention to detail is indeed important. There are also tools that can help in terms of identifying where testing may not have reached yet or where you might want to add testing. So folks who get good at testing also can leverage these tools. So if you're not the person who typically consider yourself someone who's really focused on details, that's okay. There are plenty of tools that can help with this as well. Critical thinking, one of the vaguest terms. So let's try and define a little bit more closely what we mean here. So successful testers possess strong critical thinking skills, enabling them to analyze complex systems, identify potential risks, and make informed decisions about testing priorities and strategies. Critical thinking helps testers assess software behavior critically, uncover hidden issues, and effectively prioritize testing efforts. So I think what I would say here, just to try and give this a bit more meaning and color. So critical thinking, where this comes in is, well, for a lot of testing, there can be sort of a formula or process you follow. If you're checking that a button's getting clicked, right, and some particular action's going to happen, you might do some tests to make sure the button shows up on the page. You might do some tests to make sure that the action does happen, or that in certain scenarios it doesn't happen. But ideally, someone who really can write good tests also can either know things that are unlikely to occur but may occur, um, and or has a better understanding of the overall system to better understand, okay, this test will test maybe a small functionality, but we also have to think about the downstream effects of this. So one example, you might write some functionality where this button is going to be disabled unless uh, you know unless a certain condition is met. So maybe it's like you can't click this button to add a icon or a product to your cart unless you're logged in as a user, something like that. Um, with the HTML editor, you could go in as a user and disable that disable, right? You could have the button show up and go ahead and click it anyway. So a good tester can sort of quickly think and understand, okay, what are situations where it's probably not going to happen, but maybe if someone's acting maliciously or something weird is happening on the user side, how do we account for that and make sure that there's not something detrimental that occurs? Good testers also have problem-solving abilities, so testing often involves encountering unexpected challenges and obstacles that require creative problem-solving skills to overcome. Testers who excel at problem-solving can navigate testing complexities more effectively, leading to faster issue resolution and improved software quality. I'll add this also applies to just writing tests in general and being able to work through. Sometimes the code we use to test our own code can be just as complex. So it's important to be able to function at that level as well. I'll talk about these next couple a little bit together. So empathy and resilience. So empathy in the sense that you want to be able to understand the perspective of end users. I think you all talked about this a bit with David in terms of like user experience and designing tests for users to better drive your product. Testers need this as well. And resilience, I mean, I would say this is any software developer needs a certain level of resilience to be able to keep moving when there's consistently bugs or issues continue to pop up or something really tricky is happening. But that's just as essential for folks who are doing testing. The last two mentioned here, so communication skills and continuous learning. So communication skills, effective communication is essential for conveying test results, reporting defects, and collaborating with other stakeholders. Testers with strong communication skills can articulate their findings clearly and persuasively, facilitating productive discussions and decision-making throughout the testing process. It's actually really important. I feel like it's easy to sort of dismiss like, oh yeah, you got to communicate well with people, whatever. But particularly in one of these roles where you're interfacing with probably software developers and product owners, so folks who are technical and non-technical, you need to be able to communicate well what the problem is in a way that can allow perhaps developers to offer a fix if the QA team is not, necessarily in a position to do so, as well as communicate what the issues are to a more non-technical product-focused team. And continuous learning, this is just kind of, I think, for coding in general. You'll have to continually learn new tools, technologies, languages, all kinds of different things to stay up and current and continue to improve the overall process. So it says here in summary, the psychology of testing plays a pivotal role in shaping the mindset and approach of successful testers. By cultivating attention to detail, critical thinking, problem-solving abilities, empathy, resilience, communication skills, and commitment to continuous learning, testers can achieve greater effectiveness, efficiency, and success in their testing endeavors. So all these things are needed. If I wanted to like sum this up though, I would say, whereas a software developer, your main goal is to like particularly initially, as you all are entering the industry, is to produce code, right? To solve some specific issues that maybe a customer is having or that's happening at the website. As a tester, you're doing the same thing, but you're also trying to really analyze how the overall system is working. And that skill set is something that even as a software developer, you'll want as you develop in your career. I think early software developers can kind of get away with being a bit more narrow-minded in terms of what it is they're working on and just trying to fix a feature or two. But as you grow as a software developer, you'll want the same skills that a tester would need in terms of being able to think about the overall system and yeah, just be able to have a better sense of how the overall product works. All right, so the last slide in this section here is about comparing software quality assurance and testing. So these are two different ideas. There's a lot of overlap here, but just to kind of distinguish between these two ideas a bit. So when we're talking about software quality assurance, we're often talking about processes, procedures, and overall quality of the product, which could be more inclusive than software testing. So for example, in this definition here, software quality assurance or QA focuses on ensuring that the processes, procedures, and standards used in software development result in high quality software products, whereas software testing is the process of evaluating software to identify defects, errors, or bugs and ensure that it meets specified requirements and quality standards. So again, you can sort of see here, QA is a bit maybe higher level, more about the overall processes, but it certainly is inclusive of software testing. Whereas when we're talking about testing software specifically, we're talking about avoiding bugs, making sure that functions do the things they are supposed to do, things like that. I don't think I need to go through all of these. I'll talk about the goal here. So the primary goal of QA is to prevent defects from occurring in the first place by implementing robust processes and quality standards, ultimately leading to the delivery of reliable and defect-free software products. The primary goal of testing is to identify defects and weaknesses in the software, allowing them to be addressed before the software is released to end users. Testing helps ensure that the software is reliable, functional, and meets the needs of its intended user. So as part of the overall process to ensure a high-quality product, software testing is probably part of that, but someone on a QA team may have additional responsibilities besides just testing the code. All right, we have a little, I don't know, question down here. I'll give you all, we'll say 30 seconds or so to read through this and make a guess here as to whether this individual Alex is more likely to be a software tester or a software quality engineer. All right, what do you all think? Do you all think Alex is more likely to be a software tester or a software quality engineer? You guys, guesses for the second option here. Let's go ahead and give that a shot. So in this case, it's kind of hard to see with these little things 'cause it highlights and then goes away. So I'll check it one more time. So in this case, it's highlighting. Oh, it didn't do it again. It was highlighting software tester here. Um, so I think the distinction that is trying to be made here is that we can see here, so Alex reviews software requirements and collaborates with the development team. So he's working directly with the code to ensure a thorough understanding of project goals. Throughout the day, Alex meticulously designs and executes test cases, identifying bugs and issues in the software. So this, right, relates to our overall definition of identifying defects, errors, or bugs that it meets and meets specified requirements and quality standards. So I would say like really both of these could be true to a certain degree. You could imagine a software quality engineer getting into the weeds on some days to drive some tests, but a software tester and really just a software developer would be someone who is working through and really designing these test cases. This other bit about additionally, Alex regularly communicates with stakeholders, providing detailed reports on software quality metrics and suggesting improvements. Maybe that feels like more less of a technical role, maybe I should say, but this is a normal part of the development process, is communicating sort of what's going on to other stakeholders, which could include other developers. It could also include product owners. All right, excellent, y'all. All right, we're about 30 minutes in. We're doing good on time. So as I mentioned, there's two different chunks here that we're going to walk through. One is the software development lifecycle. So that's what we'll do now. And then we'll take our break. And when we come back, we'll talk specifically about testing and take a look at a few examples. So when we're talking about the software development lifecycle, so this is abbreviated SDLC, I don't know if I've honestly seen this too much, this acronym, but I've certainly heard about software development lifecycle. So maybe I'm out of the loop, or maybe this is a hot new thing. So the software development lifecycle is a structured approach to software development that outlines a series of phases or stages for building, deploying, and maintaining software applications. It provides a systematic framework for managing the development process, ensuring that software projects are completed efficiently, on time, and within budget. So I believe we'll have a little image here. Yeah, let me make this a little bigger here. So the idea is that we are following some sort of plan of attack when developing process. At our final lesson, we'll actually talk about Agile and how it sort of flips this a little bit on its head. But we'll want to know this first before we get to Agile anyhow. So typically, or particularly in like with large products, this is kind of what we would expect to follow to deliver software. This could be delivering an entire product, but it could also be delivering a big feature of a product or something like that. So, think of like a social media site or like a Facebook, like perhaps the first iteration of this process, but then each large feature set would also follow this process as well. So we can talk through these. We're going to get details on all these things. I think on this slide, I'll give sort of the summary and then we'll move on. So with the requirement analysis phase, that's that first step. We're going to get stakeholders to identify and document the requirements and objectives of the software projects, basically setting up, what are we trying to do here? For system design, designers and developers create a blueprint or design document outlining the architecture, user interface, and functionality of the software. This is kind of like some of the wireframing that you all have done previously, right? Trying to figure out, okay, how do we expect folks to interact with this and what is the intended outcome? In the development phase, developers write code based on the design specifications. This is we're actually doing the thing, right? We're building all the different code. We have here testing, and I can talk a little bit later too about often these two will maybe happen at the same time, depending on the size of the team or who's involved. But testers execute various tests to identify and fix defects or issues in the software, ensuring that it meets quality standards. The point where it feels like, great, this code is working, product's working as expected, then the product would be deployed, and then customers would be able to interact with it. And then it's important to know at the very end down here, it's not as if you deploy a product and then you never have to touch it again. Anytime you're adding new products, you're often having to maintain those products as well. Particularly if, as you're working through other products, you start to get feedback from users and may want to start make some changes based on user feedback. All right, so for each of these sections, I'll talk through some of the activities here and the example as it says here, but we're going to go into much more detail on each of these little sections. So for the requirement analysis, this is at the very beginning of working on a new product or a big new feature. So during this phase, the focus is on understanding the needs and expectations of stakeholders, including users, clients, and business owners. Conduct interviews, surveys, and workshops with stakeholders to gather requirements, document functional and non-functional requirements, including features, user stories, and acceptance criteria. Prioritize requirements based on business value and project constraints. So for example, suppose a software project involves developing an e-commerce website. For an e-commerce website, requirements gathering may involve interviewing stakeholders to determine the desired features, such as product catalog, shopping cart functionality, payment options, and user account management. The requirements would be documented in a requirements specification document outlining the scope and objectives of the product. So this, I would say, makes it sound very, very complicated and technical. If I was going to summarize this a bit, this is a stage where you're figuring out what you want to do, right? You want to figure out what are the main features, what are we trying to accomplish with this, setting out the main goals, before it gets passed over to folks who are a bit more technical or design oriented. In the design step, you're setting up a blueprint or design document that outlines how the software will be structured and how it will function. Now, this could include designers who are focused on, for example, developing user interfaces, wireframes, and prototypes, but it'll also probably involve software developers who are defining system architecture, including perhaps hardware or software components, specifying data models, database schemas, and system integration points, and review and refine the design based on feedback and requirement changes. Having developers as part of this process is pretty important. There's been many situations where a product owner or maybe even a designer and said, how hard could it be to build this kind of feature, right? And you want a software developer there to go, well, actually, that is actually quite difficult based on XYZ reasons. What if instead we built this feature in a slightly different way to make it easier on the dev team, or that would, increase the speed overall? So you want technical folks to be involved as part of this conversation so that what ends up getting developed doesn't, take 10 years to get to the end goal, even if the designs look spectacular. So for this e-commerce website, in our example, the design phase would involve creating wireframes and mock-ups of the website's pages, outlining the layout, navigation, and visual elements. And the design document, or whatever is created from this, would also specify the database structure for storing product information, user accounts, transaction data, et cetera, et cetera. So this would be where you might have some conversations as a software developer to say, okay, how do we want to store products? How do we want to manage the cart? Is that something we're storing on the back end? Is that something that's being managed on the front end? Where is this information going to live? The development stage, that's what you all have been practicing to do. This is where we write some code. So all of these things are things that you all have hopefully practiced in some capacity, perhaps besides this last one here, but you could be writing code modules or components. You could be using different programming languages and frameworks like React. You might be integrating third-party libraries, so external APIs to pull in information and do something interesting with it. And as part of this process, as software developers in collaboration, perhaps using Git and GitHub, which we talked about previously, you would be conducting code reviews and peer testing to ensure code quality and consistency. So in this example, this is, what you'd be building, right? You might be building the front end with HTML, CSS, and JavaScript. If you're building on the back end, you could be using JavaScript, maybe using a different language like Python or PHP to handle things like user authentication and database management, things like that. At the testing stage, this is where we want to ensure that everything is working as expected. So what might be involved here is developing test cases based on requirements and use cases, executing various types of tests, including unit tests, integration tests, and system tests, identify and report defects or issues found during testing, and verify that the software meets acceptance criteria and user expectations. So as I mentioned before, development testing will often happen, if not side by side, like in very close collaboration. Sometimes it's, depending on the team size, might be the same folks doing both these things, right? Or it may be the case that some development happens that's shipped off to testing. They provide some feedback. Development continues to work on that and iterate and sort of works through it collaboratively as a team. So for example, for the e-commerce website, testing would involve conducting usability tests to evaluate the user experience, functional tests to verify features like search functionality and checkout processes, and performance tests to assess website responsiveness and scalability under load. So notice that some of the tests here have to do with sort of just functionality, but it also could be things like what happens if our e-commerce website is a huge hit and we get a million users all at the same time? How do we handle that? At the deployment stage, this is when you're deploying the application. This could be where software developers or perhaps folks who are particularly focused on developer operations, often called DevOps, get involved to take this thing that has been built, locally or with a team and actually get it onto the web. So this can be things like prepare deployment packages, coordinate deployment activities, communicate with stakeholders and end users about what's going to change, and monitor deployment processes and address any issues or errors encountered. Deployment is often pretty tricky, or can be tricky depending on your setup, and it's one of those tense moments where you're like, okay, I hope it deploys and everything works as intended. Yeah, so for this e-commerce website example, deployment involved packaging the website files, databases, and configuration settings into a deployment package. The website would then be deployed to web servers hosted in production environments, making it accessible to customers to browse and make purchases. This might also involve any sort of like wiring this up to a domain name or uh, provisioning multiple servers to make sure it's accessible to lots of different people. The last step here of maintenance and support, this is basically like as you start to get feedback, you're going to want to iterate on that feedback and make changes as needed. So you might monitor and analyze system performance, address bugs and defects, anything reported by users or noticed by the team itself. You might implement software updates and patches and enhancements. These might be big changes, but they also just might be small things like, oops, this thing is misspelled, or oh, when we click this button, something else odd happens on the page. And as part of this process, you should be doing like documentation and technical support as soon as it's launched. But you might be making this more robust depending on the type of product you're building. So, for example, for the e-commerce website, maintenance and support would involve monitoring website performance metrics, addressing any downtime, performance issues, and applying security patches and updates to protect against vulnerabilities. Customer support teams would also provide assistance to users experiencing issues with the website or making purchases. So, a lot to go through, but hopefully this process kind of makes sense overall, right? We're running the plan with requirement analysis. Let me actually go back here. This image. Come on, let's load. All right, so here we're analyzing what needs to be done. This can involve a number of different people, really, and I would say actually more likely now may include some software developers or even designers. Anyone who's well acquainted with the customer, but would certainly involve people like the product owner or any business analysts. They're trying to figure out, okay, what's the new feature we're trying to build? It then gets designed by folks who are comfortable with designing websites and building websites. The development step of this is about building out the actual code, and that can include front end, back end, full stack developers, maybe mobile developers, depending on the type of features you're building. When you're testing, you're actually going to run through all the different tests you need to make sure that that product works, and then it gets deployed. And you can see here, DevOps, the data administrator, is part of deployment to make sure that the product delivered to customers is accessible, working, available to them when they need it. And maintenance, kind of everyone gets involved here in terms of maintenance as new ideas come back and you want to iterate on those ideas. Let's go back here. So here's a little check for you all at the very end of this. So suppose you're part of a team developing a new mobile banking application for a financial institution. You and other developers are currently writing code based on the design specifications, building the software according to the project requirements. Which stage of the SDLC does this step belong to? What do you all think? Which stage are we currently in if this is the situation? Marcos says C with a question mark. Sticking a little toe out there. Anyone else? What do y'all think? Yeah, there we go. C factorial. I love it. All right, let's see what happens. Let's see what happens. Yeah, indeed. Right. So in this case, the step where you're writing code based on design specifications, building software according to project requirements, that's where you're developing, right? That's what hopefully you all would be doing. All right. Are there questions down here too? There are. Okay, great. So the importance of testing in this life cycle. And so we talked about this, in a few different ways. Testing is really integral to make sure that products work. It allows for early detection of any issues. When you're testing something out, it allows you to sort of say, oh, I can see some problems that might come down the pike here. Ensuring quality overall. This can be ensuring quality of functionality for sure and security, but also things like performance. It can be sort of what the experience is like for users. Risk mitigation. So testing helps in mitigating risks associated with software development by identifying potential issues and vulnerabilities before they impact the end users. So this is where it's really helpful to have someone who's an expert with testing to understand uh, what some of those vulnerabilities might look like. Improved user experience. So by testing, it means that some of those obnoxious bugs that you might hit as a user can hopefully be avoided. As part of testing, you may also come across and discuss compliance and regulatory requirements, which, depending on the type of application, can be pretty important, including something like GDPR, which is talking about cookies and things like that. So lots of importance there. Continuous improvement. Testing facilitates continuous improvement in the software development process by providing feedback and insights into areas for enhancement. So when you start testing stuff, you're kind of the first user of the application when you're testing, which is a great way to start to figure out, hey, there actually might be a better way to, you know, build this feature, have this feature interact with users. And by testing, hopefully you have some confidence once it gets deployed that will indeed work. Just deploying an application that you haven't tested at all or just hoping, that's not really the best strategy at the end of the day. All right, another little task here before we go to break. So y'all are going to arrange the snippets in the correct sequence to align with the stages of the software development life cycle. So we have a bunch of different steps down here. I will give you all a moment to rearrange those from beginning to end. Once you get to a good spot, I don't know, how would you share this? Maybe take a screenshot. That could kind of work. You could make your screen a little bit smaller and just take a little snapshot of this and share it out so we can start to compare and contrast. All right, I'll give you all, we'll say a minute or two to do this, and then we'll come back and discuss. All right, let's come back, y'all. I'll try and have these all up here. I know it's probably not as easy to read, but that way we can just kind of see them in comparison to one another. Excuse me. All right, so in this, let's go ahead and just try and find the first one here, right? So when we look up and down this, the first thing we're looking for is that step of requirement analysis. So which one do you all think fits this the best? So I would say this one down here, so gathering and understanding the needs and expectations of stakeholders to define the scope and objectives of the software project. I think that matches what Asari shared, and I think that matches what Drago shared. All right, so let's drag that up to the top. The next one is the design steps. There we're creating blueprints and plans before we get to the actual development stage. Seems like, what do you all think? I think probably this one, creating a blueprint or plan for the software solution, outlining its architecture, components, and user interface. That seems like that probably fits. Next, we do the development. Looks like this one maybe is already in the right spot. So writing, coding, and building the software solution based on the design specifications and requirements. Yeah, I'm just checking what you all have. Testing as well as the next one. So here, we might want to pull this one up, right? Evaluating the software to uncover defects, validate functionality, and ensure it meets quality standards and user expectations. And the last two down here says providing ongoing maintenance. We can probably drop down to the bottom. Maintenance is going to be last. The one right before release the software into the production environment and making it available for end users to access and utilize. All right, let's check it. Let's see if we got it right. Looking good. Not bad, not bad. Yeah, so all these steps lead into one another. Each step is trying to tee up the next step and make it easier for those next folks who are working on it. And the goal here is to get to really this development stage or this production deployment stage. And then the maintenance process where you come back and start to do some of these steps over again. All right, excellent. I've been talking for a while. Any questions on this content? Anything feeling confusing or uncertain, or are you wondering how you and your roles might fit in? All right, we got a learner check. Love it. All right, sorry, says all good. Looks like we got about 4 respondents. If we get a couple more, that'd be amazing. To this little Zoom survey should have popped up for you all. All right, well, I suppose we can close it out there. Sounds like most people are feeling okay on this content. There is a lot here, right? The most important, I think, things for today are the development and testing phase. That's kind of where you all fit in overall. But of course, these other steps are things that as software developers you'll need to know so that your team members may be working on as well. So it's super helpful to know what they are up to, not just wandering around and giving you tasks, right? All right, excellent. So in the next step, we're going to talk a bit more about software testing specifically, and this is the kind of work that I think you all would be involved in as software developers. Before we do that, though, let's go ahead and take our breaks. We'll take a 10-minute break here, uh, excuse me, and come back about 8 minutes after before continuing. So I'll see you all in just a bit. All right, welcome back, folks. How's it going? Did you do anything nice on your break? Anything enjoyable happened? Does anyone have any pets they go and pet halfway through this course? Nope, nothing. All right. I would just assume you all just love testing so much that you're like, I don't want to delay. We gotta get back to the testing. I understand. I feel the same way. All right, excellent. We can dive back into it. So again, we just have a little bit more to go through here. We're gonna talk more about the specific testing cycle. Uh, I will say right at the outset, this is a pretty detailed version of this. So we'll walk through this, and then I'll talk a little bit more. We'll watch a quick video that talks about the software development or software testing uh, process for software developers, and I'll show just a couple examples of what some tests might look like. So that'll be the plan for the rest of our course today. So we just talked about the SDLC, so software development lifecycle. So we're now going to talk about the software testing lifecycle. So the software testing lifecycle is a systematic approach to testing software applications throughout their development lifecycle. It outlines a series of phases, activities, and deliverables that testers follow to ensure thorough testing and validation of the software's quality and function. The STLC complements the software development lifecycle by integrating testing activities into each phase of the development process. So a few of those key components are requirements analysis. This should look pretty familiar. So in this phase, testers analyze the software requirements to understand the scope of testing, define test objectives, and identify testing priorities. They review requirements, documents, user stories, and acceptance criteria to ensure clarity and completeness. Test planning sounds kind of similar to our design step, right? Test planning involves developing a comprehensive test plan that outlines the testing approach, strategies, resources, and timelines for the project. Testers identify test scenarios, define test cases, and establish testing priorities based on the project requirements. Test case development sounds a bit similar to development, right? Test case development involves designing and documenting individual test cases that cover various functionalities, features, and user scenarios of the software. Testers create detailed test cases that specify inputs, expected outcomes, preconditions, and test steps. Environment setup. So test environment setup involves preparing the testing environment, including hardware, software, tools, test data, whatever is needed to set up the overall environment. And testers configure test environments to mirror production environments and ensure consistency across testing environments. We'll talk a bit more about this, but when you're testing code, you want to make sure the code works, of course, on your machine, but you also want to make sure it works in a situation like on production, on someone else's machine. And part of testing can be to make sure that is true as well. Test execution is the phase where testers execute the test cases designed in the previous phase. They perform functional testing, regression testing, integration testing, and other types of testing to validate the software's behavior and verify that it meets specified requirements. And then finally, the closure steps. The test cycle closure involves evaluating the test results, documenting defects, and reporting testing metrics and findings to stakeholders. Testers review test execution reports analyze test coverage, and assess the overall quality of the software. If I had to sort of summarize this process, and we'll go through each step, but we are doing a bit of planning, both on what we're trying to get done and how we're going to approach testing a code base or a piece of software, I should say. Then we go ahead and do that development and set up the environments needed so that we can test everything in multiple environments and test various parts of the code base and our user experience. And then we're going to go ahead and run those tests and report back what we found based on the tests. All right, so for requirements analysis, the objective of this phase is to understand the testing requirements and objectives based on the project's overall goals and stakeholder expectations. Some activities could be review of project documentation, including requirements, specification, and design documents, identify testable requirements and prioritize them based on business value and risk, and define test objectives, scope, and entry exit criteria. So our example here is for the e-commerce website. In the requirement analysis phase, testers would review the project requirements to understand features like user registration, product search, and checkout process. So whereas part of the software development lifecycle, part of the requirement analysis was sort of building the different features we want, in the software testing lifecycle, the SDLC, we're trying to focus on, okay, based on the things that we were trying to do, based on our requirements that we set up for this product, how do we, what do we expect to happen? What would a good process look like? For test planning, our objective is to create a comprehensive test plan outlining the testing approach, resources, schedule, and deliverables for the testing activities. So this is kind of making a plan of attack of how to build and run all these tests. So we identify testing resources, including personnel, tools, environments, define test strategy, including types of testing to be performed, and develop a test schedule, including milestones and deadlines for each testing phase. So essentially, alongside the product development, having a testing development timeline as well. So continuing with the e-commerce website project, in the test planning phase, testers would create a test plan document outlining the testing objectives, scope, and approach. They would define test scenarios and test cases for each functional area, allocate resources for testing activities, and establish criteria for test execution and completion. So we're just getting the planning done for the actual testing to be happening. For test case development, this is when you're building those test cases. So we're identifying test scenarios based on functional and non-functional requirements, develop test cases specifying inputs, expected outcomes, and test conditions, and review and validate test cases for accuracy and completeness. So for the e-commerce website project, testers would develop test cases for various scenarios such as user registration, product search, adding items to the shopping cart, making payments, all that kind of stuff. And each test case would specify steps to be followed, expected results, and any preconditions or dependencies. So a lot of words to say this is the point where we're going to start to build those tests for the particular features that match what are the requirements of this product, right? So if part of the requirements of this e-commerce platform is to be able to view a bunch of items, add items to our cart, purchase those items, those are the things that we're actually going to be testing. The environment setup, here the goal is to set up whatever testing environments are needed to be able to execute the tests. So this is usually a lot of like configuration, setting up servers. There might be some network configurations that need to happen. You might be installing, configuring testing tools, and you might be validating the test environments to ensure it mirrors the production environment accurately. I don't know if you all talked more with David perhaps about this, but just to kind of explain this a bit more as well. So we're talking about our local environment when you are running code on your machine, right? If something works on your machine, that's great. That's like the first step of what we want to do. But when that code is deployed to other machines, it might work slightly differently. A sort of analogy here is, you all have probably seen in different browsers, websites can show up with just some minor differences. It could be sort of like how a border does or does not have a little bit of a radius, or perhaps how some of the text shows up. So it's kind of minor differences are the same things that can occur with all kinds of code depending on the environment. So there's plenty of ways to, safeguard your code against that. And often I think it doesn't show up, but depending on the type of things that you're doing, it may matter. And some of those things could be things like storing or loading files, uh, anything that's like a script that depends on a script uh, for like your computer that requires a certain file structure. Those are things that can change depending on the environment. And so as part of testing, we want to make sure that we have a good understanding of what the different environments are and that we are testing our code, not just locally where we know it works, but in other environments as well. So our example here for our e-commerce site is, testers would set up a test environment that replicates the production environment of the e-commerce website. So it would be built, the server that this code is going to get deployed to would have the same specs, have the same configuration. Everything is as similar as possible. So this may involve installing web servers, database servers, and configuring network settings to simulate real-world usage conditions. And it notes here a couple tools that might be used to help execute this. For test execution, the objective is to execute test cases and scenarios to validate the functionality, performance, and reliability of software. So this means we're running the tests. We're trying to record anything that can be recorded that is useful to like share back to potential stakeholders. And of course, if there's any kind of defects, we can either retest those to make sure any fixes that came through can be addressed, or maybe rerun it to make sure that those failures are not one-offs in some way. Um, and in our example, this would be us validating, all the key functionality, maybe checking to see how the website does under a huge amount of address, like a lot of different people visiting at the same time, and reporting back those details. And so the test cycle closure step is really just us wrapping up, summarizing test results, and preparing to send those off to various stakeholders. So we review test execution results and assess test coverage against the defined test objectives. Objectives. The word here, coverage, the idea being that have we covered all the various parts of the application that are really critical to the functioning of it? And do we have tests for those areas? We're going to prepare test closure reports summarizing test activities, outcomes, and lessons learned, and conduct a post-mortem meeting to discuss testing process improvements and gather feedback for future projects. Kind of just wrap up the overall process. In this example, they would, these folks would prepare a test closure report documenting test activities, any defects, and recommendations, and would have sort of a meeting afterwards to talk about the overall process. Whew, all right, lots of stuff. So let me do a little bit of a recap here. So early on in the process, like with requirement analysis and test planning, what we're trying to do here is understand what the requirement is for the product and come up with a plan of attack of how we are going to test to make sure that all the functionality we want and need to be working are indeed tested. So we're trying to make sure we have full coverage, we have a full understanding and tests for the key components of our application. When we're doing the development and environment setup, that is when we're trying to go ahead and set up all the different tests that are going to run. Those might be tests in code. They might also be more automated tests, might be like load tests, like just trying to send a bunch of users, like simulated users to the website, and setting up the environments that we are doing this testing so that it mirrors real world situations as opposed to just what's happening on our machine. And then in these last two steps, we're running all those tests, getting all the data we got from the tests, and passing that back up to stakeholders, and perhaps talking about the process and how we could improve it next time. So a lot to discuss there, but the process makes sense, right? We do a bit of planning, we actually make the tests that we want to, and then we report back on those tests. That's really what this process is about. All right, let me go ahead and give you all, I think there's just one question here. Yeah. 30 seconds or so to complete this question. You are a tester assigned to a project developing a new tourism website. You're currently developing a comprehensive plan that outlines the testing approach, strategies, resources, and timelines for the project. You're also identifying test scenarios, defining test cases, and establishing testing priorities based on the project requirements. Which phase of the STLC does this step belong to? What do you all think? What do you all think? What do you all think for this example? What phase do you think we're talking about here? All right, we got a couple differing opinions. Any other thoughts? That's it. Oh no, I've sent everyone else to sleep. All right, let's go ahead and try them out. So, um, I think there's a couple we can exclude, as I think, sorry, and Dragosh are pointing to. So I think in terms of test cycle closure, I don't know if that entirely makes sense here. It sounds like we are still in the middle of the process here. This closure step comes at the very end. So to me, it doesn't really sound like that's going to be one of the options. For execution, I don't know if it necessarily sounds right either. It says here we're identifying test scenarios, defining test cases, and establishing testing priorities. We're not running the tests themselves, right? So in terms of and B, so A is referencing our test planning, and B is referencing our test case development. Let's go ahead and just try out A here. Cool, and that is indeed the answer. This little checkbox thing is just so weird. Yeah, it like doesn't check the second time. All right, well, it is indeed a test planning. So we can go back over to this one to take a look. So our objective here in test planning is to create a comprehensive test plan outlining the testing approach, resources, schedule, and deliverables for the testing activity. So that does indeed sound like what is happening here in terms of we're planning things out. We're not actually getting to the stage of actually writing those tests just yet. All right. Excellent. So last little recap here. Perhaps this feels obvious. I'll just read through a little bit of this. So we talked about the SDLC and the STLC, so software development lifecycle and the software testing lifecycle. The software development lifecycle, the idea here is that it is overarching. This is the overall sort of product development cycle, whereas the software testing lifecycle is really just about testing those products. So the SDLC encompasses all phases of software development. STLC specifically focuses on the testing phase within the SDLC. So it's sort of a vertical within the overall process for the software development life cycle. So this is a pretty structured approach. And following this kind of make sure that organizations are conducting systematic and comprehensive testing and development for their products. I do want to sort of just take a little aside over here. I think for software engineers, the process doesn't feel this detailed, although there might be management roles that are thinking along these lines. So I just wanted to share a video and then just an example or two of what software testing looks like that you all may be engaged in. So we have this video over here. Let's go ahead and watch this. If you are not able to hear, let me know, but I think I've turned on all the various things we need to turn on.
Software. It's not like engineering something easy like a bridge, where you start with a blueprint, build it to spec, then forget about it. Software is dynamic, with a lot of moving parts and requirements that evolve over time. Developers build apps on top of a mountain of abstractions, and nobody fully understands how every layer works. That's okay, because we just need to make sure that our code matches the requirements of the product. Test-driven development is scientifically proven to reduce defects and improve the maintainability of a codebase, but it does require some additional effort. One option is manual testing, where a human being clicks on every button and fills out every form, then assigns a bunch of Jira tickets so they can be backlogged by the developers. But that's not very efficient for a large-scale product. A better approach is to use automated testing tools that allow developers to write code for the sole purpose of testing the main application code. In a codebase, you'll often find files that end in .test or .spec. Inside, you'll first find a line of code that describes the feature or thing that's being tested. That's known as a test suite, and it contains one or more individual tests. An individual test usually starts with it, followed by a description of what is being tested. The idea is to describe the behavior of the code in human-readable terms. Inside the test, the code will be executed, then one or more expectations or assertions are used to check that the code produces the expected result. If the expectation returns false, then the test fails. If it's true, it passes. Test runners, like Jest or Karma, can run all your tests automatically in the background or on a continuous integration server before you deploy. Now, there are many different automated testing strategies that you should be aware of. At the most granular level, we have unit testing, which is designed to test individual functions or methods, like does this function return the proper value when given the arguments of A and B. Then we have integration testing to determine how well different components or modules work together, like is the component able to use the database service to get data from the server. At the highest level, we have end-to-end testing, which usually happens in a mock browser or device and simulates actual user behaviors like clicking on buttons and filling out forms. It's like having a robot to do all your manual testing for you. And that's not all. There are many other types like performance and smoke testing, which I'll explain in my upcoming test-driven development breakdown. Hit the like button if you want to see more short videos like this. Thanks.
All right. Hopefully, as you all are watching that, you saw a few things that maybe looked kind of familiar. So I just want to walk back through here. So over here, so when we're talking about testing at the software engineering level, it might look something like this. Our code over here is a simple function that, excuse me, adds two numbers. Although if you look at the code, it looks like it's subtracting. So there's something going on there, but oh well, that's our example. In this case for the test, we have a description of what should be happening. We run the code, and then this expectation code, this is something that would be a library that would give you access to these kind of functions. So actually, as the code is now, we would expect this test to fail because currently it's subtracting as opposed to adding. You all, maybe you've seen some of this. I think when you all are working with React, you might have seen like a app.spec.js file and probably just deleted that and gotten rid of it immediately because we haven't really worked with those. But all kinds of different frameworks and JavaScript allows for testing, and yeah, often you'll see it as one of these, having these kind of like descriptors attached to the file name. I'll talk a little bit more about the syntax here in a moment. But this right here, you also might have noticed that this looks like GitHub, right? And so we saw that actually we were working with GitHub the other day, that there was sort of an option to run something automated when we were doing our merge. This is the kind of test that would get run, right? So before something gets merged, we might have a bunch of suites of tests getting run to make sure that, hey, it's not going to break anything immediately. This is often a requirement as a software engineer before you merge your code, or even get someone to look at it, is that all the tests need to pass. I think that was kind of the last thing here. Yeah, I guess, this part, I just want to kind of call out. It says up here, React Trello board. So we have all kinds of different tests to test different parts of our application. We talked a little bit about unit tests, and those were described over here. That's testing some individual function. Integration tests, and you can see here there is some React code. The idea is that we're testing two or more services connecting to one another to make sure it does indeed work. And with these end-to-end tests, we're really testing the overall functionality. So whereas a normal, like a regular person could run all these tests manually, we set up automated suites to perform these actions, so we don't have to just have one person sitting around and being like, all right, Bill, get back to dragging these cards around and make sure they still work after we've made a change, right? So this way it's automated and can be run whenever we make a change overall. So I hope that gives you all some idea of what the testing process really looks like for software developers. Often you're working, I would say, most of the time you're going to be expected to write these kinds of tests, which are essentially unit tests. And then depending on the types of applications you're running or building, doing some of these other types of tests will just depend in terms of something like an integration test or an end-to-end test. I just wanted to share kind of what these look like. This is an open source application I worked on a long time ago. I did not write these tests, but this is the application itself. Make this a little bit bigger. Let's go. This is for a course. How do I describe this in a short way? essentially people would make courses on this dashboard. And so there are a bunch of tests to make sure, in this case, that this particular utility object that has a bunch of functionality associated with it will continue to work. And so you can see here in terms of some of the different descriptions here, we have a describe block that was mentioned in the video. This is describing the function itself. And then there's a number of different tests that test particular functionality. So for example, this course utils.generate temp ID function, there are tests here that test whether or not it can create a slug from the term, title, and school, whether it trims unnecessary white space, whether it collapses multiple white spaces into one space, whether it creates a slug from title and school when the term is empty. And so all these kind of follow the same format where you have some of the inputs that get defined, the output, and then we have this expect the output of that function to equal something specific. And so these are the kind of tests that you might typically write. And again, these are very similar to the tests we've written in the past few weeks when running our sorting algorithms and things like that, where we've been testing different array inputs. So this is kind of the process one might follow. All right, let me pause there. Any questions about any of this content? Folks just feeling overwhelmed by the information. Let me ask a different question. If you had to summarize testing for someone in your life, maybe who's not as technical, or they're just asking you like, hey, what did you learn about today in your course? How would you describe it? How would you describe testing and software testing to someone else who's a little bit less technical? It's a tough question, but we got 55 minutes to figure it out if we need. So that's okay. Take your time. So based on what we talked about today, how would you describe testing to someone who, again, maybe was just asking what you learned about today uh, in your course? All right, we got that several people are typing. Love to see it. All right, keep them coming. Thanks, Dragosh. So Dragosh says, going over and over again on any possible issue you might encounter, only to potentially have someone find bugs on day one after launch. A bit of a pessimistic view, but you're not wrong. You're trying to do your best to avoid a bunch of issues. There will, of course, be other issues that crop up. Juan shares a way to anticipate things that can happen, edge cases, and make life easier while interacting with software. A bit more optimistic of a view. I appreciate that. Yeah, so we want to anticipate what could occur and hopefully make life easier, certainly for our users, but also for ourselves. Not testing code, and as that code grows, is only going to lead to more headaches for you as a developer. And certainly for the users as well. So it's a way to sort of make things easier for everyone involved with whatever the product is you're working on. All right, let's get one or two more from you all. All right, Asario shares, software testing is the process of checking to ensure that a software function functions as it ought to. Yeah, exactly, right? You write some code and you want to make sure, hey, does this code work as I thought? You want to write some tests for that to make sure it does, and ideally have automated tests that can continually run so that if something changes in the future, you can still test that it continues to work. Excellent. All right, not bad, y'all. So just to wrap up, and there's one little last activity here. So overall, we talked about today, we talked about the software development life cycle, and that is about developing software overall. When I say software, it sounds a little like Microsoft Word is software. But we're talking about any kind of application, any kind of product that we're developing that interacts with technology in some way, right? So we were talking there about a process that we want to follow so that the product gets to the end of its development life cycle and is as good as it possibly could be before it really meets real users. We also talked about the software testing life cycle and how like professional software testers or QA folk might approach testing a large system or product. There are a bunch of different roles that interact with testing. Certainly QA team, software testers, product owners, they have a hand and a role in testing, but software developers do as well. And some of those last little bits that I showed you all, the video and just the example of code, that's where as a software developer, you might be engaged in writing code to make sure that your code does indeed work. We have a last little reflection here. There are 3 statements that it wants you to put in correct order. I'll give you all a minute or 2 to solve that, and then we'll come back together. We'll say just until 40 after, maybe a few seconds afterwards. So go ahead and arrange these 3 statements. We'll just take another 30 seconds or so. All right, excellent. Thanks for sharing, Dragos. So I believe what it's asking us to do is sort of match these statements to the ones below. So in terms of analyzing and explaining the concept and significance of testing in software development, right, we can drag this one down. Identifying and describing the role of testing in each phase of software development and software life cycles. You'll have answered a bunch of questions to get this to work. And I can list and describe various roles and responsibilities of a software tester. Oh, interesting. You can like indent. Oh, that's kind of cool. All right. Hopefully that works fine. So we've done a lot today and covered a number of topics. Again, the goal of these kinds of lessons is to give you all a survey of some really important topics in software development. I understand that all of these things may not have stuck. That's a-okay. Hopefully the overall ideas and concepts are making some sense and give you a little bit of a foundation should you hear about any of these terms moving forward. I'll add, I think one of the first ways that you all may interact with testing will be if you are practicing algorithms, code challenges on sites like Code Wars or HackerRank or something like that. Those activities often have tests associated with them. And so you'll see some of the testing code that I've shown you earlier, something like it, show up on those examples. So at the very least, being able to understand what's happening with tests and why they're giving you a red output, even though it seems like your code should be working, is pretty important. So that might be one of the first ways that you all interact with it. I think that's all I have for today. So we have one more lesson before the class is over. That's going to be our Agile lesson down here. We will cover that, I believe not Monday, but Tuesday. If I remember correctly, Juan, I think we have
Yeah.
Monday off. Okay.